So we're going to start talking about definite integrals. So definite integrals. Indefinite integrals, we're just looking for like the equation kind of above. We think about it going up a level. So we had like x squared, so if you integrate that, the equation that is above that would be like 1/3 x 1/3 plus whatever, plus c, right? So you're just looking for an equation. So in a definite integral, what we're looking for is, if you think about this as like a velocity graph, if this were meters per second, if I found the area under the curve, I think some of you guys know this from physics, so if I found the area under the curve of meters per second, what does that tell me? It tells me meters. So when you go down a level, like when you take the slope, so if I start with position, and I take the derivative, that gives me velocity, right? I take the derivative of that gives me acceleration. So when I'm taking the derivative, that's the same as taking the slope. So going this way is derivative slash slope. Going backwards is integrating, out of room here, but is integrating slash area. So if I have an acceleration graph and I find the area between 2 points, that tells me the velocity between those 2 points. If I have a velocity graph and I find the area between 2 points, it tells me how much distance I traveled between those 2 points. So we're just basically going to run through the same stuff we did in derivatives and just do everything again, but backwards. So the first thing we do is learn how to estimate it. So we can integrate. I mean, I can tell you how to find like the real answer, but the estimate part is on the AP test. So Riemann sums are the first thing that we talk about to estimate. I'm going to show you a few different kinds. But this would be, like I'm trying to estimate the area under this is y equals x squared, between 0 and 3. And they broke this up into 6 rectangles. 5 rectangles. 6 rectangles. Yeah. Okay. And so there's 4 different kinds. I'm counting just below my. There's 4 different kinds. There's right endpoint, left endpoint, midpoint, and trapezoid. Trapezoid is just an average of right and left. But I want to show you what they look like, and then I'll show you how to calculate it. So the right endpoint means like for this given interval, so this is between like, what is this? How is this broken up? This is, like those aren't my 0.5s. That's why it's throwing me off. They're about like 3 7s or something. Crap. There. Okay. Well, now, but now it was all the way over 0, and now it's like 0.5 for the width. Now it makes sense. Okay. There's a little slider like off the screen, so it's my fault that it looks like that. Anyway, so for a right Riemann sum, this region between 2.5 and 3, we're going to just pretend it's a rectangle. And then the more rectangles we make, the area that the estimate will be more and more accurate, right? I'll show you in a second. You'll be able to see that easily. If I'm using a right-hand method, I go to the right endpoint of the interval and pretend that's the height of the that becomes the height of the rectangle for the whole thing. If I were using a left endpoint method for this endpoint, then I would go, okay, well, I'm going to go to the left-hand endpoint and pretend that's the height of the rectangle the whole time. If I were using a midpoint method, I would go to the middle of the rectangle, go up until I hit the graph, and pretend that was the height the whole time. So let me just run through a couple of them. Like I'll show you what they look like on the graph, and you get a better idea than me just drawing them. So first of all, if I make more rectangles, what happens to my estimates? It gets more accurate, right? If I make fewer rectangles, like that's obviously a terrible estimate. So then this is a right-hand endpoint because I'm using for each of these rectangles, I'm pretending that the height on the right-hand side of that rectangle is the height the entire time. In this case, will right hand method overestimate or underestimate the true area? It will overestimate. What is the characteristic that is true about this graph that makes us overestimate it? Let's say we do that. So just keep that question in mind. Over here, does right hand method overestimate or underestimate? Under. So if I go left, now the left hand endpoint becomes the height for that entire region. The left hand, so between -3 and -2. I don't have it like perfectly there. It won't go in the middle. Oh, this is driving me crazy. Alright, whatever. So between these two endpoints, -3-ish, -2-ish, the left hand number is -3, so we pretend that's the height for that entire rectangle. If I were doing midpoint method, this is a little harder to see, but I'm going to really wish I could just type my numbers instead of playing this stupid game. Is this fun for you guys? There, that's good. All right. So, like, this is an interval between 3.5 and 4. So what they did was go 3.75, go up, and then they're pretending that's the height the entire time. Trapezoid rule. It's hard to tell. It's not just like perfect. It looks perfect on this, but what trapezoid rule is doing is going, okay, we're going to go to the left-hand endpoint, we're going to go to the right-hand endpoint, and we're going to draw a line between them. So it's pretty close, but it's not as perfect as it looks on this situation. And the way you find trap is just you'd find the left-hand method and the right-hand method and average them together. So let me just show you a couple other equations, what they look like. So let's say e to the x. So there'd be like your left-hand method. There's your right-hand method. I can make more rectangles, make it more accurate, make fewer, make it less horribly inaccurate. Here's 2 plus sine of x. Right-hand method, so I'm going on the right-hand endpoint of each. Left-hand method, left-hand endpoint of each. Midpoint, so I'm going like in between, in the middle of the rectangle. And then trapezoid, which again is not as perfect as it looks. Here, what if I make like... So if I make them like very few of them, you can see it's not perfect, right? But if I make more, it starts to get pretty close. Show any more graphs. Does that make sense what we're trying to find? So let's go through how to do it on the paper I gave you. You won't have like a scrolling graph in front of you. So. So you got to be able to do it 2 ways. First way is with a table, which is easier. Second way is with just an equation. But the first thing you would do if I give you an equation is make a table and then do it from a table. So basically, the table is kind of the starting point in any situation. So this is asking us to estimate the area underneath G of W between 0 and 20. And they gave us these endpoints. And I want you for each one of these to do left hand, right hand, and trap. Trap is trapezoid. And that's just the average of the left and the right. So once you find the left and the right, you're almost 90% of the way to the trapezoid. So the left hand method, and all these are is rectangles, right? You're just adding up the area of a bunch of rectangles. What's the area of a rectangle? Base times height. So rectangle goes from 0 to 4. So if you envision a graph, we got a rectangle at 0 to 4. That's the base of it. I don't know how to make it yet, but I know that's the base. So what is the size of that base? It's 4 units, right? Between 0 and 4 is 4 units. And then for the height, we're going to do the left-hand method first. So you look at the left-hand endpoint. So you look at the left, so if you're envisioning a graph, 0 and 4, which number is further to the left? Is the 0. And then the height at 0 becomes the height of your rectangle. So I'm just going to do 4 times negative 1. So this 1 right here is not the left-hand endpoint of this interval, so it doesn't get used. So it's like these two and then the left-hand value. So when I shift over to my next rectangle between 4 and 5, what's the base? 1. And then for the left-hand method, you use the left-hand x value to find the y value. So the left-hand x value here is 4, right? And the y value there is 1. So my next interval between 5 and 9, the base of that rectangle is 4. What's the height that I'm going to use for that rectangle? 0. So 5 and 9 are your two endpoints. The left hand, out of those two, the leftmost one is 5. You find the y value from that. Plus, so from 9 to 10, my base is 1. My height is the left hand's x value determines that, so that's negative 1. And then from 10 to 20, so the base of that rectangle is huge. And then the height would be the left hand value, which is 1. So in a left hand endpoint, there's one value in the chart that will never be used. Which one is it? The one underneath all the way to the right. Because that can never be the left hand value, right? Correct. In a right hand endpoint method, which point will never be used? It'll be that one. So let's go ahead and find that. Let me do it yet. So I think it's 6. Let's do right hand. Similar, except you're determining the y value from the right hand endpoint now instead of the left hand endpoint. So the bases are all the same. The base is still going to be 4 because you're still going from 0 to 4. But now I use the right hand endpoint and pretend that is the y value for that entire base. Yeah.
Could on the right-handed whatever, could you go from right to left instead of left to right?
Yeah, I mean you're just adding up 4 rectangles, right? So addition to order doesn't matter. If that makes more sense to you, that's not a bad thought. I'm gonna keep going the way I'm doing it though. That's okay.
Yeah.
So what he's saying is, let's just go backwards. Then. Let's start at the right and go to the left. That might make more sense to some people. But I'm gonna go 4 times 1. My next base is 1 times 0. Because out of 4 and 5, the right hand most point is 5, so that is the height that I use. Plus 4 times negative 1. Plus 1 times 1. Plus 10 times negative 1. One benefit of going the same direction both times, you can kind of scan the bases of your rectangle a little easier to make sure they're all the same, I guess. But that's not a big deal. So what's this? 4, negative 9.
Yeah.
Those are pretty far apart. And then trap would just be the average of those. So 6 plus negative 9 over 2. So negative 1.5. Questions on what I'm doing there? Does that seem alright? Yes, no, man. Okay. There's a fourth method called midpoint. We could not do midpoint on this table. So for midpoint, what you would do, and we'll do it later, but I would go, okay, my first base is between 0 and 4. What's the midpoint of 0 and 4? 2, so I would look at 2 to find my y value. Well, I don't have that. So you need a lot of information to do a midpoint. Like you need all the points in the middle and everything. So they don't ask you that one very much, but they do. They do it enough that we next week you'll have a test on this. And I think this is real life, but I don't know. I gotta double check.
No, like real life, like in the business world, like in 20 years from now.
Problem with that is I've only ever done this. I mean, it's like if you want to talk about the position velocity acceleration, this is finding the area under a curve. So if I give you any rate, like I'm filling up a pool at 50 gallons per hour, I can figure out how long it's going to take to fill up the pool. Although I don't need calculus to do that. It's like a simple example. Anytime I give you a rate, if you want to know the amount, you get any rate. So maybe it's like dollars per, if you're a business, dollars per product that I make. How many dollars will I make if I make, you know? That helps out. That's the best I try to give you. Should I do another one, or you guys want to try it too? Do two. Yeah, I just noticed that. I think it just gives you left. It might be that on 5-3 it just gives you right. I might have done on 1 through 4 if I left, and on 5-8 if I do right. I'm not quite sure. So that'll be fun to find out what we're doing. What? As long as one of them works. Yeah. You guys get what I'm getting for 2? Yes, no? Getting no feedback here. You good? Questions? Yeah. So the base is going to be the distance between these two. So between 0 and 3, so your base is 3. And then you go to the right hand number and look for the y value. That's it? Okay. Okay, shut up. 5 through 8 of the right hand. Okay. So on the answer key, I'm asking you to do a little more than like the system set up for. These first 4 answers are left hand. The next 4 are right hand, and then after that, the directions tell you specifically what you're supposed to find instead of just like putting a number there. Are we good to go forward? All right, let's go to number 9. Yeah.
I know it's
No, you're good.
what me like because I'm cocky about it, but on the right hand, I didn't get -5. I got 6.
So is it like a matter of you adding these up differently, or you have different things than I do?
Yeah, no, I've got the same thing.
So then you just can't add multiply.
Yeah,
There's nothing I can do about that at this point. You're just kind of stuck with your brain. I guess. No, I don't. But that's fair enough, right? Like you know the process, so you're good. Okay. Let's look at number 9. So this is probably the toughest guy, and it's just like tediously annoying somewhat. But let's do number 10 so that I have a little more room to write number 10. So they tell you, no wait, that's not what I want. I'm sorry. I want to do midpoint. So 11. Let's do 11. So they tell me that I want 4 midpoint rectangles. So in the first one, they give me a table, so like I didn't really have to think about how many rectangles there were going to be. But if there's going to be 4 rectangles and I'm doing it across 4 units, what's the size of each rectangle going to be? It's going to be 1. So I'm going to have 4 like intervals. And I'm going to make my own table. In midpoint, you don't really need to find the values at the endpoints, but I'm going to do it anyways because that's what you would do in like all of the other versions. So if you get an equation, the first thing I'm always going to tell you to do is make a table. So let's just do that and make a table. And then you'll see in a second why it's not totally necessary for midpoint, but I think it's still helpful. So I'll plug those numbers all into the original equation. So 0 gives you 11. 1 gives you 12. 2 gives you 11. This is 8, I believe. This is 3, I believe. I'm gonna need some verification though, so I check that. You got what? Oh, okay. I said 5. Verify. No, I just. You can get your calculators out if you want. Because you're gonna need this. Gets annoying. So, yeah, you might need calculators for this. For the midpoint, I'm gonna look at this first rectangle. The first rectangle on this graph is between 0 and 1, right? What's the base of that rectangle? So what's the distance between those two x values? Is 1. But for the height, I go by the y value at the midpoint. Not the so the y value at the left hand point would be 11. The y value at the right hand point would be 12. You can't just look at this and say the y value at the midpoint is 11.5. It might be in this case, it might not, but it's not just going to be the average all the time. So you actually have to plug in. That's why this table is annoying for a midpoint. I really need 0, 1, 2, 3, and 4. Not what I really need to know. For midpoint, I really need to know 0.5, 1.5, 2.5, and 3.5. Does that make sense? So you're grabbing the y value of the midpoint of each interval. So these actually become kind of irrelevant. And what you really want is 0.5, 1.5, 2.5, and 3.5. But you kind of need both tables because the top table tells you like the base, like how long the base is. That's where we get the 1 from. And then I'm going to use this to get the y values of those in the middle of each base. Midpoint's annoying. I'm not going to pretend it's like fun to do. I would way rather do like the use substitution integrals than midpoint. And again, they put on the AP does like just enough to make you have to do it. Did you guys see 11.75? So that's what I mean. Like if you just looked at this and said, oh well, right between 0 and 1 is 0.5. So right between 11 and 12 is 11.5. It wouldn't work. So this is a parabola, right? It's not going to be like a constant difference. It's going to be different rates because it's curving. That would also be 11.75. So 12 must be like the peak of the parabola. subtract from there, I actually have to take this. Hello? Hello? Are you guys getting the same Y values then? So then the midpoint kind of combines these two tables. So this first interval had a base of 1, and we got the height from the midpoint, so a height of 11.75. Our next, so every base is a base of 1, right? What's up? Pretty good. Did you get it? So if you add all those up, hopefully you get 39. The answer's not my main concern, but do you understand what I'm doing? You understand the process I'm going through? Yeah, Sheila.
If it's over the interval given using 4 midpoint instead of using 2,
Yep.
would you just go
So let's talk through that.
0 to 4?
If there's only 2 rectangles and you're asked to go 4 units, and there's only 2 rectangles. Your first rectangle will be from 0 to 2. So what's the base of that rectangle? 2. And what value would you plug in to find the height of that rectangle? 1. And then you go 2 to 4. So what's the base of that? 2. And what value would you plug in to find the height? Would be 3. So yeah, and if they could ask you 8. Could say there's 8 of them. I don't think they would do that on the AP test. But then each interval would be like 0.5. And then you would just cut in the middle of each one to find the midpoint. Fair enough? So you're expected to know how to do, and there'll be one of these on your gateway. It'll be either LRAM, so they're really called, left is called LRAM, that stands for left, and rectangle approximation method. So then there's also RRAM, which is right, MRAM, and TRAM. I mean, really, you just have to know that the RAM means rectangle approximation method, and then L is left, R is right. Do I have to write all those out? I don't want to write them out. R means right, T means trap, M means midpoint. RAM means rectangles. Oh wait, so it's not TRAM, it's like, well, that one's just called trap. It's like trapezoid. Trapezoid. Real awesome process.
Trap is something also process.
Something, yeah. So you have this to work on, and you have con on this stuff also. And that's your practice for this. Again, there'll be one of these on the gateway. It'll be either find LRAM, or find RRAM, or find MRAM, or find trap. You don't really know which one.
Is it going to be like the other gateway where you have 3 of them?
Yeah, so the rules are the same.
And what time are all the, or what day are all the times? One's due tonight, and the others are due.
This one I think I may do Tuesday, so we'll go over this again in class on Tuesday. And I'll probably give you a little bit of time in class on Tuesday to do the con also. So it'll just be review this, do some a warm up or something, and then be time. Hello? Hey. She walked by my room, but I was in the middle of teaching, and she walked back. She left, which is I was in the middle of something, so I wasn't exactly inviting. Oh, okay. I'm available now. If she wants to come now, if you find her. Okay. Yep. Any questions? Anything I can help with? Seem all right? we'll learn how to do this for real when we're not approximating. So I understand it's kind of annoying to learn how to approximate when you're going to learn the real way soon anyways, but we're trying to learn the method and it's on the AP test.